All right, so I'd like to share an engine rebuild I'm doing on a Honda CB350 engine. My favorite motorcycle of all time. In 5 years of production, the CB350 sold over 250,000 motorcycles, making it one of the best-selling motorcycles in history. So let's get started. All right, here's our head. We're gonna take this apart, disassemble, get it cleaned up. I've got some exhaust gaskets in here. I'm gonna pry those out. Valve spring compressor. I'm going to use a magnet to pull out those collets. There's one. There's the other one. There's a lot of spring pressure, so you have to be careful not to let the tool slip. Inner spring, outer spring, and top. And that's an exhaust valve. All right, let's do the others. Right, now that I have the valves out, I want to take off some of these stuck on gaskets. I don't want to damage any of the surfaces. So I'm going to use this flat razor blade and carefully scrape out underneath without gouging into the aluminum. All right, so I want to bead blast this and get the finish back and take the carbon off. But before I can do that, I've got to get all the oil off. No liquids inside the bead cabinet. So let's give it a wash. All right, let's take a look at the Harbor Freight bead cabinet. It's modified like most people do because they don't work all that great out of the box. I've got an electrical box here. I've got 2 outlets and a power switch. And of course, 1 outlet is for the shop vac for exhaust. Here's a regulator. I run the beads at about 60 PSI feeding into the cabinet. Down below, I've got a modified outlet. So here's where the beads come out, and it's got a tube, that's your air bleed. Kind of works like a carburetor. Air comes in, you get a nice mixture coming up the hose. Inside, The glass is covered with a window screen, and this does a remarkable job of keeping the glass clean. I never need to go inside and wipe it. This will go for months and months. Also in the back, that's the exit vent, and it's covered by an extra shield that helps dust go up, but not a lot of excess beads. Heavy duty gloves are from Harbor Freight also. And the tray is shortened with a heavy tray support underneath. This gives more room so you can put larger engine cases in here. Next, we've got some very high output LED floodlights, and these do a good job. These are a lot brighter than what comes stock. All right, so let's take a look for beads. I use Ballottini. These are round glass beads, and the size you want. A good place to start is a 70 and 120, 140 US sieve, and that's a good size for getting the beads. You can see I don't use a whole lot inside, and they do break down after a while. You can refresh it and keep them fresh for a good finish. All right, here's our head. It is nice and dry. There's no signs of any liquid in there. Now, before this goes in the cabinet, every one of these thread holes has to have a sacrificial bolt threaded into it. This is so no glass beads gets down into these holes. If you didn't do that, it would be a major hassle to get those beads out. You may not ever get them completely out. So let's thread these bolts in and cover up all these threaded holes. There you go, that'll do it. All right, that went really well. Very clean. Now still dusty. Let's take these screws out. Let's blow some of that dust out off of this. All right, last job. This still has dust on it, so we're going to give it a nice scrub and wash. I like to use S100. Easy on the aluminum, does a great job. All right, here we go. Clean head. So we washed it, got all the grease off, bead blasted in the bead cabinet, and it looks really nice. It's got a nice shiny. The bead blasting kind of peens over the surface, takes the stains out. It's like little round spheres that peen it and get all the gasket surfaces clean. They're all clean and flat. Intake's clean and flat. And ports are carbon free, so that's great. And also the seats here. So let's check some threads. Spark plug threads. Nice and smooth, no grit, full threads, nice and tight. Okay, that's good. I'm going to check all of the M6 threaded holes. Make sure there's no grit or debris in there. Good threads, you can see them all. intake also, flat surfaces, no gasket material. Bolt threads in nice and smooth and clean. So one guide here is boogered up on the top. So we're going to replace that, and the other three look pretty good. We're going to clean the valves up and inspect the seats, how concentric they are with a fresh valve. So we'll do that next. Here's our wire wheel, and we're going to take a look at the valves that came out. Wow, a lot of built up carbon. It's kind of wet, like oily here. Faces look like they're recessed, but we'll hit it with the wire wheel and clean up this carbon. Here's our intake. Yeah, there's the faces are completely recessed. There's a deep groove in them. These will have to be replaced. Here's an exhaust. So getting some of the carbon off. The faces are in better shape, but there are some little pits. So these should be replaced also. So we're going to replace all 4 valves. All right, well, I'm going to replace this one guide here. It's damaged on the top. I'd like to use the stock cast iron guides. Now I happen to have a nice spare. It came out of a used head. It's in great condition. It's polished clean, no carbon. And then we have a couple tools. First tool is a drift to push the old one out. And then another tool to push the new one in. We're going to do that in the hydraulic press. And this is just a simple tool. It's going to press on the flange. We're not going to hammer on the guide itself because that'll damage the top or the bottom. So we're going to keep that on the side. We only need to get it up to maybe 200 degrees or so. So we're going to use the MAP gas and warm it up evenly. Check our temperature. 150. And we'll give it a little more. Okay, here we go. All right, turn our head around. It's still warm. We're going to clean up the bore that the guide came out of before we put a new guide in there. Yeah, still hot. Here's our replacement guide, and we're going to use some Goodson press fit lubricant in the bore on the guide. And we're going to let that sit for a minute to let it tack up. Okay, here we go with our tool. We want to press it in nice and concentric. And we're home. All right, head's cooled down. We're going to be checking these guides, see what kind of condition they're in. These are some good valves. Valves go in smooth, no binding. The guide that we just put in over here is a little bit tight. That's not to be unexpected, because when you press a guide in, it may swage down a little bit. So I'm going to ream that out with a 0.2750 chucking reamer, straight flute. Get that started in there. Still a little tight, we'll go up to the next size. There we go. Beautiful. All right, so I want to measure the valve guide wear to the valve. And what we'll do is we'll lift up the valve and we're going to measure it on the dial indicator. Limit is going to be 0.003 of an inch. So we're going to wiggle it. And we're getting about 2.5 thousandths, so that's within limits. That's good. All right, to cut the valve seats, I'm going to use my Surdy Micro. It's a special tool cut for cutting full radius valve seats. The first step is to take this index tool and we put our valve in there. And we're going to bring that pointer to exactly where we want the valve seat to be cut on the face of the valve. This is about 0.010 of an inch back from the outer edge of the valve right there. So now we have an index. Now we set up the tool itself. This is a full radius cutter here. So we've got our 45-degree valve seat cut, and then we've got a leading full radius and a trailing full radius. So it gives best airflow. So now we have our pointer, and we set that up close to the tool, and then we adjust the position of the cutter itself so that the outer edge is exactly at the tip of the pointer. Now our tool is set up. Now we put that into the 30 micro. So here's our 30 micro. We're going to take our tool with the cutter on it. This is a pilot that's going to be spinning inside the valve guide so it stays perfectly concentric. So we'll put this into the tool, snug it down, and then that pilot goes right into the valve guide. So I'm going to clamp this down and position the tool, and then we're going to cut it. I've got the 30 clamped in. The tool is positioned just above the seat. So the function of this is that this is locked in so the pilot is perfectly concentric and stays rigid. If I turn this on the top, it brings it down lower until it starts to cut. I stop, advance, and I turn it. Now we're cutting the seat down on the bottom here. I'm going to keep cutting until the full 45 degree is cut, and then some of the leading and trailing radius. Okay, intake seat is cut. Now I want to verify exactly where on the face of the valve that the seat is actually going to be. I want to verify that the seat is in good conditions, concentric all the way around. So what I'll do is I'll use a little bit of valve grinding compound, and we'll lap it in just a little bit. I just use a little bit of hose to spin it. And let's see how I did. Oh, that looks beautiful. Perfectly smooth, concentric all the way around. It's at the outer edge, but not completely at the outer edge. Let's see what the seat looks like. Oh, that's nice. You can actually see that there's a radius leading into the 45 degree. The 45 degree is a nice matte finish after a little bit of lapping in, and that looks beautiful. Good to go. Okay, the best method I've found for checking your valve sealing to make sure it's perfectly no gaps is use a flashlight. I'll go into the intake port here. If I raise it up a little bit, there's lots of light flowing around. If I seat it, light finger pressure, I can see there's no light at all coming from the outside here. All right, one more check. I'm going to hold the head up to the light. Here's the valve. I'm going to look through the intake port, and I'm going to spin it and see if there's any light leaking through. There's no light at all. That's going to be a perfect seal. All right, let's check out our valve springs. First, examine them for any signs of rust. These are nice and clean. They're smooth. There's no signs of rust. We know that these have been in an oil bath their entire life. So these first look pretty good. Next, we're going to measure the free length. So there's a limit. If they're sagged below a certain limit, they need to be replaced. That limit is 1.882 inches. So let's measure these. 1.89. 1.90. 1.91. 1.90. These are all within specs, so we might be able to reuse them. What we'll do is we'll measure the spring pressure on a scale next. So let's go ahead and do that. All right, here's our scale setup. So to test the spring pressure, what we'll do is we'll compress the springs to a specified dimension, 1.22 inches. So we'll set up our inside caliper. Okay, right at 1.22 inches. Put our spring in. All right, let's compress it. And what we have, this measures 146 pounds. That's within spec. All right, time to install the valves and valve springs. I'll start out with a little bit of oil on the valve stems themselves. A little pre-lube. And some oil on the valve seats themselves. So the springs have a certain orientation. There's a tight wound end that goes towards the head on both the outer and the inner. Two collets. It's one down, three to go. There we go. All right, here's a crankshaft. It's going to require some special cleaning. The reason is that underneath the side of the bearings here is a special groove that collects splash oil, and that's how the big end of the connecting rod gets lubricated. So oil gets collected in this groove, and it goes across and lubricates the big end. Now this always catches sludge. It almost works like a sludge trap, and also inside the pin it collects sludge too. So let's degrease it first. We'll wash overall, then we'll have to scrape out the groove and scrape out the inside of the pin. Got a bent piece of welding rod. I'm going to go inside the pin and kind of scrape out the debris that's in there. It's going to take a fair amount of flushing to get that debris through the bearing rollers and out. A little special touch, we'll use some Scotch-Brite and clean some of the corrosion off the lead and the copper-coated rods. All right, now we have our crankshaft cleaned up. Bearings turn smooth, there's no roughness to them. There's a specification in the manual for free play of the bearing race. So we set up a dial indicator, we turn it vertical up and down and take a measurement. The replacement limit is 0.02 of an inch, and we're measuring about 0.5 thousandths. Let's move this over to the connecting rod. That'll give us some vertical play. And we're not getting anything. Again, the service limit is 0.02 of an inch for vertical play, which requires replacement. So this is a good crank. Let's measure the run out of the crankshaft. Support on just the center bearings on a V block. And we're getting about 1/2 of an inch. The service limit is 0.8 of 1/1000, so this is good. Here's our engine crankcases. They've been, after disassembly, degreased, dried, bead blasted. We get this nice peened finish from the glass beads. All surfaces inside and out. There's a lot of sludge, typical in the bottom. That's washed out with the parts washer. Same thing in the upper case. Nice and clean. Let's look at a few things. We want to make sure that every threaded hole is clean. No debris, no blast media in it. All good threads all the way around. Also, we want to make sure that the windage tray in the bottom doesn't have any big cracks in it, otherwise it will break up. You don't want sheet metal broken up and flying around inside your engine. And let's look at a couple things before assembly. One is this is where the oil pump bolts onto, and there's oil galleries drilled through. This is one through hole that's drilled down to the other oil gallery, and it has a plastic bead in there to block off this passage there. On the upper case, oil travels from the right hand side through this oil gallery. There is a peened plug there, but we have to be careful that there's no glass bead or material that's through this gallery that goes across the backbone of the upper cases. These two holes are where the oil goes up to the top end, so these holes need to be unblocked and no glass bead material inside this oil passage through the cases. Okay, first part of crankcase assembly, we're just going to be installing the kickstart shaft. I've already got the return spring and a stir clip on there. Let's put a drop of oil on. That's all we need. Put that in the cases. Now keeping this boss pointing up, and the return spring, that's where it hooks. Pinion gear. Spring washer. Spring. Ratchet. Now ratchet, the wedge I'm going to be pointing down. Washer again. Spring. And arm. Now the arm has to be going in between the bosses down in the cases. If I rotate the kickstart down, the wedge is going to grab onto the arm, and you can see that's grabbing good and pulling the arm back because it's ratchet spinning. I can put my last washer on and this last circlip. Now, sharp edges out. Be sure that the circlip is not distorted and expanded, which can often happen when it's taken apart. They're very tricky to take out. Just make sure it's snapped into the groove. There you go. So the action, when it's engaged, the ratchet is engaged and turns the pinion gear. When it's fully retracted, pinion gear spins. All right, to install the crankshaft, two center bearings have oil feed holes here that are passages from the backbone passage. So they're going to have locating pins here and here, so that the holes go right through the bearing shell and into the oil passage. Another locating pin over here that goes in. Cam chain goes around the crankshaft first, but let's check out this cam chain. If I take a good sprocket, lay it over the teeth, I can see that there's no lifting of the links. That means this whole chain is nice and tight and great condition. This will add a little oil. So first pin gets located and that drops right in. Second pin goes in. Third pin. We know the crank is seated because the bearings are tight in their bores. Center bearing cap has orientation. There's a notch on the front half and kind of a flat on the rear half. Does get a little bit of pre-lube on the threads. And that gets bolted in. Final torque, 15 to 20 Newton meters. Let's install the shift drum. This is our orientation. We've got shift forks. The outside ones are identical, but they're flipped in orientation. The middle one is identifiable because the center span is smaller in diameter. If we look at the hard chrome, they're in good condition on the shift forks. A little bit of rubbing on this one. And if there's signs of gouging, that means it was a bad shift and it could be bent. These are in good shape. Drop of oil. They all have a smooth turning on the drum. There's no binding, there's no burrs, so that's looking good. drum goes in and it gets located side to side by this locator. It's held captive once it's tightened in by a lock washer. It's got a spring in the center and also a ball. So we're going to install that right now. We'll get that final tightening later. So here's our shift forks. They're each located in their groove by a solid pin, so we'll drop those in. The pins are held in by a circlip. Pin. Circlip. And last pin. There we go. Okay, I'm going to install the transmission shafts. We've got first our main shaft. So this side is where the clutch itself, clutch drum spins on. It's nice and smooth. There's not a lot of damage on it. Ball bearing on one end and a roller bearing on the other end. Just add a drop of oil. Get those to spin. So let's take a look at the dogs. We've got square dogs on the main shaft. I'm looking for rounded edges on both mating dogs, and they're in great condition. They're nice and square. They're fully machined. It's a great quality gear set. I'm also looking at the faces of the teeth themselves. I don't see any galling or pitting. So this is going to get locating by a half round on one side and a pin on the other side. The roller bearing, it has an oil hole that goes through the bearing shell, and it needs to mate up to the hole in the cases themselves. So let's lift up the center shift fork and drop that in. And boom, drops into place. So I know that the bearing is fully seated because it's no gap and flush to the bearing bore in the cases themselves. And over here is no left or right movement for the ball bearing. Countershaft, we've got, this is where the sprocket fits on this end, and there's no rust. It looks in good condition. We've got a bearing surface here that the oil seal rides in, and normally these get grooved pretty bad. You get dirt in there, it gets spun around. This is in great condition. Ball bearing on one end, and roller bearing on the other. Again, we've got a half round for locating left and right. And we have a pin to locate the oil hole, which in this case is a large slot. So slot, slot. Go lift out both of the shift forks and drop this in. And boom, nice spin. So right now, if I want to, I can shift through each of the gears with a screwdriver, just by turning the shift drum. You can watch how it engages and disengages each of the gears. There we go. There we go. It looks great. Nice and smooth shifting. Well, I'm going to install the bottom case half. These surfaces get a little bit of thin sealant on them, and then they'll mate together, and then we'll bolt the bolts together. Let's give a little cleaning on the mating surfaces. No oil, no grease. Got 2 oil seals to install at this time. Camshaft seal. And we're going to put grease inside the grooves. This will give the best service life for this oil seal. Do not put any sealant on the outside of the seal. It was never intended from the factory. It's not necessary. We've got push rod seal. I'm going to put grease in the groove also. These seals are spring loaded and they'll give a long service life. This one only needs to sit in there flush. All right, let's put some sealant on it. Only need to put on one case half and not both of them. There you go, that's what we need. Thin film. Permatex Ultra Gray, that's my choice of sealant. Now before we mate them, there's 2 dowel pins, forward and back. When these cases go together, they should meet with no force. Just like that. We'll start with the big M8 bolts. Oil the threads. Just get them seated. Now for the M6 bolts. Again, a drop of oil. Let's get those heated. Final torque on the M8s is 15 to 20 Newton meters. On the M6 bolts, it's about 10 Newton meters. Crank spins free, counter shaft, and main shaft. Two more bolts in the top cases. Just like that. Okay, I'll be installing a couple wheel seals over on the left side. I'll start with the Shiftshaft seal. Again, no sealant on the outside of the seal, and we'll grease up the grease groove in the middle. Just getting grease in between the two seal lips that are in there. And that will be easy press fit in with your finger. Just flush, that'll do it. Next up top here, at the end of the shift drum, there's going to be a nose sticking out. And that's going to be for the neutral electrical switch, neutral light switch. Grease that up also. A little bit recessed in there, so I'm going to use a socket. There we go. Sits flush in there. Now on top of that nose, we're going to fit the neutral switch, and it consists of a rotor that has a little locating pin. To fit that over, screw that in. And then the switch itself will go underneath, and it has a screw. So when the drum rotates, It's in neutral, it makes a contact between the ground of the engine case themselves and this electrical contact, which will accept the neutral switch wire. Next is the shift drum locator. I like to call it the detent. It stops the shift drum into each of the 5 gears and also helps with neutral. So we'll slide that on. And this gets a bolt with a special stepped washer underneath it and a flat washer on top of it. So I'll slide back and forth. It'll accept spring pressure to hold the gears into its proper gear. Last step is the spring. Now stock setup is having one coil spring like this to provide detent pressure. I'm going to add a short bit of extra spring, and that's going to increase the spring pressure. There's some situations on certain bikes when they get hot, they'll shift from one gear to the next gear, and they'll actually over rotate the shift drum. This will help prevent that. There we go. It's got a little pigtail sticking out the end of the spring that'll hold it into a hole. Let's try this out. There we go. Nice stiff detent spring on the shift locator. Next we'll have the shift shaft. We'll go in there. A little bit of grease will help it out. Slide that in. So often these can get bent or damaged and they will not slide in and out easily. This one does. This is in great shape. We'll slide it underneath and put it on the pins underneath the end of the shift drum. So we've got a spring that will hold it completely up all the time. And also down here, to return it to its neutral position, we've got a spring down here. Be sure that that spring is engaged onto that pin, so we can shift in this fashion. So drain cap, it's sealed by an O-ring, so let's install that. We installed the locator for the shift drum, but we haven't tightened that, so let's do that. It has a locking tab. So to inspect our clutch plates, easy way to check for warping. Now there's no burn marks on the steels, and to see if they're warped, we can hold 2 of them together and see that they're laid completely flat, and flip one over and they still remain completely flat. So there's no bow, no warpage in those. We're gonna oil these up and let them soak for a minute. set this aside. So here's our clutch basket. We want to inspect and see if the bearing surface is worn out at all. So all you need to do is put that over the main shaft and give it a wiggle, and there's practically no free play on that. This thing is like brand new. So that's terrific. We have to inspect our oil pump. This has been cleaned. I'm going to pull off the screen, make sure there's no debris underneath it. And also I can see that there's a steel check ball that's down inside the body. I'm not going to remove that. And I can hear it wiggling around. I can see that's clean in there, so that should be in good shape. So for the installation, what we have is the piston itself. A little oil on that. It's located in by a pin that just floats. On our basket, put a little bit of oil on the eccentric arm. So this will spin around as the engine's running. The arm will turn the piston inside and out, back and forth. And that's ready to go on. Here's our oil pump gasket. Put a drop of oil on it just to help it stick onto the pump body. We've got two primary drive gears. They're going to act as like a mesh together. First, the thick washer. And we'll install one with the stepped facing the outside. Now the whole clutch basket and pump. Then the second gear, they'll all need to mesh in between. The two scissor gears have rubber bushings inside so they can move a little bit. The stepped area on the gear goes in facing in. And now they're meshed together. The pump has a special lock piece. That spins nice. And when the bolts for the oil pump body are tight, then we can crimp the lock piece in place. Next, this is the clutch inner. It starts out with a steel plate already attached. That'll go into the basket. Here's our circlip for the clutch inner. It's going to hold the whole basket on. So we need to make sure that's in good condition. It has sharp edge on one facing and the other edge is rounded. So the sharp edge is always faced towards thrust. So in this case, it's going to face outwards. It's a good sign that it snaps into place, that we know it's fully seated in there. All right, let's install the clutch plates. They've been soaking for a few minutes. We're going to alternate between the fiber plates and the steel plates when we install the pack. The steel plates have a sharp edge and then a rounded edge. What we'll do is we'll put the sharp edges facing outward, This should allow a smoother engagement when the clutch pack is squeezed together. Next we've had our push rod, clutch push rod. I'll have the rounded edge facing towards the clutch pack. And then our clutch lifter. I'll put a drop of oil on that too. This is our pressure plate. Smooth surface, no damage, looks in great shape. That's ready to go on. And then our clutch springs. Right, going to install the oil filter rotor. This is a centrifugal type of oil filter. It spins on the end of the crankshaft. Oil goes in, debris gets spun and gets stuck to the inside of this rotor, and clean oil comes out. First in, the conical special washer actually says outside on it, so that goes in. Next, a tab lock washer. And then a special nut. The nut is requiring a special tool. Rounded end goes in first, flat end is out. Now to keep the crank from spinning while I tighten it, I'm going to use a soft piece of aluminum here. I'm going to put it inside the gears and jam the two gears together like that. just like that. So last, there is a locking tab. I'm going to bend down. And that's going to lock the nut. So for the rotor cap, it has a cast-in steel insert. That insert rides against a oil through piece and it spins. To retain good oil pressure, that needs to be a flat surface, no grooves or damage to it. Cap takes an O-ring. And tines need to mate up between the grooves in the rotor itself. And then the circlip. Circlip does have a sharp edge and then a rounded edge. Sharp edge goes out towards the thrust. Let's make sure it's seated completely in the groove. Just like that. Here's our starter motor. And let's take it apart and see what kind of shape it's in. One end has our planetary gears, plenty of grease in there, and the spindle spins in a sealed bearing. It feels perfectly smooth, so I think that's in good shape. We'll leave that there. End cap, plenty of dust in there. That's residue from wear on the brushes, but the brushes have a lot of life left in them. I only need to remove this one wire to pull this end cap off. And that's our brushes. All right, we'll clean this all out and then I'll give it a repainting. Give it some new lube on the bushing on the end here. Time to assemble. First thing I'll do is I'll get some 1000 grit and just polish up the commutators on the stator here. fresh grease in our planetary gears. Pack some grease into our bushing at this end. And the other bush. Here's our plate holding the brushes, cleaned up. The blade has tabs and notches that need to align to let it sit in place. There we go. O-ring. And 2 thrust washers. So we'll need to align the alignment marks. That. That. All right, here I go with a starter motor installation. Got my O-ring on there. I'm gonna grease this up. Hope that slide in without damaging the O-ring. And 2 screws. Starter clutch needs 3 rollers, 3 springs, and 3 spring guides. Start with a spring guide and a spring. That's going to drop into its hole inside the housing here. Hold the spring in while the roller gets dropped in. And it's free to move. That's the next one. All right, I've got 3 rollers in there, 3 springs and 3 spring guides. Got a little bit of oil. So the starter sprocket's got a nice smooth surface on it. It's not gouged out. Looks to be in good shape. And to install that, I have to spin it. I know it's seated all the way when it's flush against the boss here. A little oil on the bushing. I need to put the chain on and both sprockets go in at the same time. I've got my key, so the key's going to have to go straight into its groove, and both sprockets at the same time. There we go, nice. Sprocket stays centered in its position with this guide. There we go. Now it's heated. Get a little oil on our rotor bolt. It's a special flanged bolt. And we'll tighten that down. Again, to keep the crank from turning, I'm going to use my soft piece of aluminum and jam it in the gear teeth on the right-hand side of the engine. There we go. And we can see the one-way clutch works just perfect on the starter. All right, I'm going to install the left engine cover. First, the stator wires go through. There's 3 bosses to get both the stator in, and this wire rubber grommet goes into that notch there. Now for the gasket, I've got the 2 dowel pins already installed in the crankcase. Gasket goes on dry. You do not want to put any kind of sealant around this passage here. This is the main oil galley. If a bit of silicone or sealant breaks off, it can clog your oil flow to the top end. And down here on the lower case, we can put a drop over the grommet. Just a little. Just like that. Now for our cover screws. Now the cover's on. Now I can rotate the crankcase. So I'm going to restore the finish on my oil filter cover. This is a convolute wheel. Time to install the clutch cover. Let's start with the oil filter cover. This gets a through piece with a spring underneath it. And then we have a small circlip that gets pressed over top. The wire circlip fits into a groove. It snaps into place. Be sure there's an open end to the circlip. Be sure that's not adjacent to one of the two bosses there holding it in place. And that's spring loaded. 2 O-rings for this cover. One goes on the cover itself, and then the other O-ring goes inside the cover over here. And a little bit of grease helps the O-rings go in together. Gasket, I've already got the 2 dowel pins installed. Wheel seal gets grease in the groove, as all of the oil seals do. Tiny bit on the outside helps it go in. And that's a press fit. Like that. So before I put the cover on, not a bad idea to pre-lube the oil filter with some oil. The oil filter cover has, again, an O-ring, oil through, be sure that it's free and not binding. And it has holes. The D-shaped hole goes up, and there's only one way for it to go on. Like that. All right, let's look at the pistons that came out of this donor engine. So I already bead blasted. There was plenty of carbon on the dome. All the carbon's cleaned out of the grooves and so on. I'm not happy about, there's corrosion pits on the dome. Not quite happy about that. Let's take a measurement, see what kind of size we're at. Okay. The size of the piston is 63.96 millimeters. Standard size is 63.97 to 63.99. So we are worn a bit undersized. Let's take a look at what our bore clearance is. Use our dial bore gauge. Zero it in. All right, let's see what size our bores are. Okay, at the top, where we're going to expect the most amount of wear, we're up about 0.08 of a millimeter for clearance. In the middle, we're at about 7. And down at the bottom, where there should be less wear, we're actually at a standard clearance of about 0.05 of a millimeter. So I think what we'll do is we'll give this engine rebuild some fresh pistons. All right, before we put new pistons in, I want to give this cylinder a crosshatch and attempt to take out some of that slight taper that's in the cylinder. Now, to take out a taper, you're going to need to use a rigid hone. Ball hone or other types of hones just aren't rigid enough. They won't take out a taper. They'll only give you a crosshatch. All right, let's take a measurement and see what we've got. That's good. Most of the taper is taken out. And a nice crosshatch. That'll be great. All right, now we've got some new pistons. Let's take a measurement and see what our bore clearance is. All right, we're right at 63.99 millimeters. Zero in our bore gauge. Okay. That's at 5/100ths of a millimeter and 5/100ths and about 4.5 hundredths. That's well within tolerance for taper. All right, we're good to go. All right, now we've got a fresh crosshatch. Cylinders you're going to need to drop the oil before assembly. That'll be enough. There's another method if you don't have micrometers or dial bore gauge to measure piston clearance. Take your piston, clearance we measured at 5/100ths of a millimeter, and with a nice clean fresh feeler gauge, slide it in like this, pull to one side, and there should be a nice slip fit coming out, just like that. Now I just verified and measured that it is 5/100ths of a millimeter bore clearance. All right, we can measure the piston ring end gap. Just put the ring in the bore, square it up with the piston, take a measurement. This is measuring 0.5 millimeter, which is what it should be for a brand new ring. So when you're installing the piston rings, they each have a letter mark on the top, and that needs to be facing up. And stagger the gaps so that they're not facing each other. So when I install the pistons onto the connecting rods, I'm going to start by putting one circlip in. Be sure that is set in the groove, and the open end of the circlip is not facing where the notch is. Large cutaway is for the intake valve, and there's an arrow pointing towards the exhaust. Now for the second groove. I do have a rag down here in case the circlip pops out. I'll be able to catch it. That's in and that's seated in the groove. A little oil. And the circlet. That's seated. All right, cylinder base O-rings are there to keep oil from traveling up the cylinder and possibly leaking out. The proper O-ring size is 2 millimeters, not this 2.5 millimeters supplied in my gasket kit, so that's no good. All right, O-ring's installed. It needs to be flush with the top surface, otherwise the base gasket's not going to seal and seat properly. Okay, a word needs to be said about Camchain tensioners. This is a stock one. Both rollers are made out of just a hard rubber. So these were known to fail even when these bikes were brand new. If you're going to ride at 80 miles an hour all day long, these can break up and fail on you. These are probably suitable if you're going to be keeping your speed limits and RPMs down, maybe cruising at 65. A better option is this one. This I made out of hardened steel, and this won't break. This one you can maintain reliability if you want to ride at 80 miles an hour all day long. The third option is a slipper tensioner. These were designed and manufactured by Ken Miller. These are suitable for full-on racing at high RPM. All right, next I'll install the cylinders. I'll start with the Camchain tensioner. Basically 2 pieces and a dowel pin. Roller goes on first, the arm goes around. Then the hollow pin goes through the center. The pin has a couple notches that need to point up. And to keep it in the up position, there's 2 keepers. I want to be careful not to drop these in the engine when I put them in. This one. And that's the other. So the keepers keep the pin in the up position. There's oil holes, so that's going to be required to keep that pin in the correct orientation. Base gasket goes on dry, and the reason is that there's 2 oil holes in the back of the cases, so oil flow to the top end goes up to these rear studs. If there were any sealant, there runs a risk of having a piece of sealant break off and blocking your oil flow to the top end. so no sealant. A couple dowel pins will locate the cylinder on the front. The cylinder has a Camchain guide. It just drops in from the top, and a pin that's located in the bottom. The cylinder also has a very generous chamfer on the bottom of the cylinders, so it should slide over the rings pretty easily. There. Just like that. All right, next to install the head, start with a couple dowel pins. Head gasket goes on dry. Again, oil passage to the top end comes up through these two rear outside studs. And you do not want to have sealant and risk it breaking off and clogging oil flow to your top end. Head gasket surface is clean, dry, no gouges and no residual gasket material. Left and right are held down by a couple M6 bolts. All right, here's our camshaft. For point of reference, this is what's later style, also called the skinny cam because it's skinny in this area here in the center. If I look at the lobes, they're pretty smooth. There's no big score marks, no burn marks. Looks good. This is the journal. This is where the bearings actually ride on is. Looks perfectly smooth. Let's take a measurement. Let's see, 21.95 millimeters. Okay, so according to the service manual, a brand new journal size should be between 21.94 and 21.96. So that's right in the middle of a brand new journal size. So that's perfectly good. If this were worn under to 21.92, that's the replacement limit. Here's our bearings. So it's a plain bearing where a cam journal rides right on the aluminum surface here. It usually gives very good life, but if the engine was starved of oil, then it could be a problem. You'll find wear here. This is pretty smooth inside. I see one little rub mark. Let's take a measurement here. And we're right at 22 millimeters. So according to the service manual, standard size for a brand new part is between 22.0 to 22.021 millimeters. So that's like virtually brand new. If this were worn to be a size of over 20.05 millimeters, then that would be replacement time. I use my pick, pull up the cam chain. It's my cam sprocket. There's a L mark, and that goes on the left-hand side. That can drop in for now. 2 dowel pins on the rear outside. A gasket for a cam box. Rounded nose goes towards the front. Cam box. Rounded nose goes towards the front. And then 4 screws. There's my sprocket. Here's our tachometer gear. It's going to take 2 thrust washers. We'll hold the washers on. Some grease. It's a very tiny one here. And then a larger one on the other end. And on top of that goes the oil seal. Again, we'll put some grease in the seal itself. And we'll press that in with a socket. Like that. For a little more prep, put some oil in the bearing. That one's ready to go in. This is our camshaft oil seal, and we'll put some grease in there, and that will press in the cam bearing. Another drop of oil. That one's ready to go. Let's take a look at our rocker arms. Our pads are nice and smooth. There's no galling or excessive wear on both the cam lobe end and on the valve stem end. So that looks good. Yeah, these are good rockers here. Now, the skidding cam takes only one type of rocker, and there's a 312 marking on them. If there's no marking or any other letters besides 312, they don't belong to the skinny cam. All right, installing the camshaft. Get some timing marks lined up on the rotor. There's an LT mark that lines up on the stator. So those are lined up. And on the sprocket, there is a L mark with a flat line, and that flat line needs to be parallel to the top surface of the engine here. That looks good. Camshaft has a pin that gets pointing up and the cam goes in. I want to hold the sprocket up so that my timing doesn't get lost. And put in my first bolt. This will be the all thread of the specially hardened cam sprocket bolts. Just putting in finger tight, holding the sprocket up. I could put it on my first cap. The left side has a notch for wires that goes towards the rear. The right hand cap has tachometer drive facing forward. Now I'll check my timing again. LT to LT, and the L mark is flat across. That's perfect. I'm going to rotate the cam 180 and put in the second bolt. If I look at the camshaft, the threads have a recess in them, and that matches up with the shoulder that's on the bolt. I install these bolts with a little bit of medium strength blue thread locker. That's enough. That's finger tight. Let's put thread locker on the other bolt. There we go. These bolts need to be tightened quite tight. I'm going to hold the crankshaft with my 14mm wrench and tighten these nice and tight. There we go. Okay, when I install the rocker arms, as long as I keep one or the other of these caps on, I could take one off and the timing is retained. These rocker shafts are on eccentrics to allow the tappet adjustments. I put them in, gonna rotate them until they're completely loose. On the end of the rocker shafts is a little mark. those should point outwards. I've got O-rings on the rocker shafts, and I'll need to align the gasket. It only goes on one way. When you put the gasket on, you'll need to verify that it matches the shape of the engine case. Like that. And 4 screws. Same for the other side. I'm going to rotate the crank till the lobes are pointing down. Align the gasket. And the cat. Four screws. Ready to button up the top engine cover. Before we do that, we'll get plenty of oil on the cams and rockers. Some of the cam chain, and then more underneath where the lobes are. There's little oil baths that the lobes will dip down into and splash oil around. So having extra oil up here is a good thing. There's a drain hole in the back here, so I need to align my gaskets to go over that hole. Baffle plate, again, the hole is in the rear. That goes over like that. And then the last gasket with that hole over there. Next, I'll need to lube up each of these threads before I put the top cover on and the top nuts. Like that, and then the cover. These are special thick washers that go over the studs. We're going to tighten these down all evenly. Final torque is going to be 20 Newton meters. There we go. Here's our cam chain tensioner. It's got a few different parts. It's got a locking bolt, which has a locking nut, a washer, and an O-ring. Spring goes in first, and then the push rod. Push rod has a flat surface that goes up, and the lock bolt, tighten down on that. I'm just going to retract it all the way like that to install it. Gasket and bolts. You can see the tensioner is loose right now. This tensioner device will take up all that slack in there. So now I'm going to let the spring inside do its job. If I loosen the lock bolt, you can hear it spring forward. I want to take up the free play on the front of the cam chain. So I'm going to rotate it forward a little bit, put some tension on it, loose, and then tighten. Now I can verify if the tensioner is working good. I'm going to rock the crankshaft back and forth, and if I look at the camshaft, it'll be completely synchronized. There won't be any free play in the cam chain. That looks good. And last of all, snug down that lock nut. That's the tensioner. Okay, time to adjust the valves. First I need to bring the piston to top dead center on this left cylinder on the compression stroke. Easy way to do that is I put my finger over the spark plug hole, rotate it forward. I'm going to feel the air push my finger up. When it stops pushing my finger, I stop. Right there. To check that the piston's at the top, I just stick my screwdriver in. Yeah, it's right there. You could also check that it is LT mark on left cylinder, top dead center. And both rocker arms should be loose. Got a flat washer and lock nut. Rotate each rocker towards the outside like this till it closes, and then bring it up a little bit. The intake is about 2/1000 of an inch on the feeler gauge. I close it. I want to slip fit. Hold it and then lock the lock nut. I should be able to wiggle it. It's loose. And slip fit with the feeler gauge. And that's that. The exhaust is 4/1000 of an inch. Again, rotate towards the outside. Get the slip fit. Snug down the lock nut. It wiggles, slip fit, and now we're done. I'm going to install the points plate and points cam advanced mechanism. Starting with the advanced mechanism, I've got this taken apart and cleaned up. There's grease inside the grease groove on the cam. The cam is polished so it's nice and smooth. There's bob weights with 2 springs, and the springs retract fully to the closed position. There's an index mark on the cam itself, and that points towards this arrow on the points plate. Like that. There's a notch on the back of the plate, and that coincides with a pin that's on the camshaft. That gets held in by an M6 screw. I'm going to put a light smear of grease on the cam itself. And on the points plate, there's a felt pad. I'll put a little bit of grease on that too. I'm going to line this notch, 2 notches on the points plate to this notch up here in the cam bearing. I'm going to start out with them centered like that. Points plate gets held in by a couple screws. I'm not going to fully tighten them yet. Next, I need to set the opening gap on the point. So I'm going to rotate the crankshaft. I can see that the left point is open, and that gets set at 14/1000 of an inch for opening gap. That's a little bit loose. loosen the set screws a little bit. And there's a notch and a little peg that allows me to make an easy change for points gap. And a slip fit at 14 thousandths. And lock the set screws. Rotate the crank to open up the right hand points over here. Measure that. A little bit loose. Feels pretty good. Now to be sure I've got this all set up correctly, like before, I put my finger over the spark plug hole and rotate the engine forward. I'm going to feel a rush of air, and just before that rush stops is when the points will open. Points are closed. When they open is when they fire. So static timing like this, I could use an ohm meter. And the way that works is when it's closed, there's continuity. When the points open, then it'll be an overload. Points are closed. And they're opening. The LF mark is just a little bit off, so I'll rotate the points plate just a little bit. LF is left fire. That's at idle speed. Points closed. And they open right there. Another adjustment. And check again. And there we go. Points open exactly on the LF mark. Now I'll snug down the points plate. And let's do the same thing for the right hand side. There's my air. And we're going to check the static timing on the right points. A little bit off on the firing mark, the F mark. So instead of moving the points plate, I'm going to adjust the points gap just a little bit. and another adjustment. Right there, just about perfect, right on the F mark. Now I can snug that down. Put my cover on with a gasket, grommet in the notch, gasket, and then the cover. Last is a cover. First is a gasket. I've got a little thin smear of grease on it because I'm going to want to take this cover off each time I want to check or adjust my points, which is periodic maintenance. The screws have a O-ring. And there we go. I'm going to assemble the sprocket cover and the clutch lifter mechanism. There's a ramp here with an adjustment screw. This gets a fair amount of grease on it. There's a notch that needs to be aligned with the casting inside the cover. This keeps the ramp from spinning. On the outside there's a washer and a nut. And then the plate with three balls goes in. And finally the clutch lifter itself. There's a spring. And finally a ball bearing. These are carburetor intake boots. All right, here's our carburetors. The bodies have been cleaned already. The parts have been cleaned. I'll explain each of the circuits and the parts as I assemble it for you. Let's take a look at the choke. Choke shaft is spring free. We've got a flap inside and spring loaded, so that stays closed when it's closed. Butterfly shaft is spinning free. Add a drop of oil. Keep that shaft lubed up. Initial setting. This is the idle speed screw. All the screw does is keep the flaps open a little bit when it's closed. Initial setting is close the screw until it touches, and then one turn in. And that keeps that flap cracked open a little bit. Let's look at the slow speed pilot jet. That will go into this hole over here on the side. Jet's number 35. In kind terminology, number 35 jet is actually 0.35 millimeters of bore diameter. So it's a hole size of 0.35 millimeters. I can look through the jet with a magnifying glass and see that there is a clear round hole. I can also take my pin drill. Let's measure this. This is at 0.33 millimeters. So this should go through just fine. And I can use that to clear any debris. And it goes through just fine. So be aware, I'm not drilling out the hole any larger. I'm just clearing out debris. If we look at the circuit from the fuel side, from the float bowl, fuel goes up into these passages, but then also gets mixed from air. The air bleeds are up top here. This is for the pilot. Air comes down, mixes with fuel, and then it comes out through holes here. We've got two small holes, which are initial, and a third hole, which is also controlled by the fuel mixture screw. This is a 722A body. 722A and subsequent bodies have an improved fuel mixture screw, which they add a flat washer and a O-ring. This just improves the fuel quality at idle. Spring washer O-ring. These are closed in all the way till they touch. And then initial setting for this is 1 1/8. So half, whole, and then 1/8. All right, so the pilot circuits basically cover from idle up to about quarter throttle. About half throttle range, that's controlled by a slide needle and the jet that goes around it, and also the primary main jet, which is one of these two little press fit with an O-ring. We'll put those in next. There's two ends. If it's confusing, what we do is put the numbers on the outside, and then the O-ring gets pressed in. Fuel comes out through a nozzle. This is the primary main jet nozzle that goes in here. It's just a press fit, does not screw in. It'll push in there. And then the primary main jet pushes in top. Now this gets held in by this spring, which we'll add later when we put the float bowl on. All right, let's look at our slide needle. This is the slide. Here's a needle. It's held captive with a clip on the inside. And here's what the needle looks like loose. So it's non-adjustable, made of brass. It has a taper. Okay, a taper slides up and down through the needle jet, which is the bore machined into the top of this emulsion tube. It's an emulsion tube because it has ear bleed holes drilled into the sides of it. So you've got a main jet that presses against the bottom, air bleeds, and needle jet. Now, since these are both made of brass and they move against each other, these can get worn out. If your engine has 8,000 or 10,000 miles, these are certainly worn out and should be replaced. Now, later style carbs, they made improvements by having the slide needle made of aluminum with hard anodizing. So hard anodizing lasts longer, and the needle jet would be chrome plated. So those can last 20 or 30,000 miles before they're worn out. So the emulsion tube is a press fit. It drops in. And then the main jet, again, numbers are facing out, O-ring against the carb body here. Now again, that gets held in by this spring. We'll put that spring in last when we put the float bowls on. All right, let's take a look at our float needle and needle seat. This brass piece here is a needle seat. So the needle slides up and down, shuts off fuel flow. Now what's critical is that the bore, the inside surface of this seat, is polished and smooth. It's common for it to get corroded. So to polish it, I'll take a rolled up piece of 2000 grit sandpaper, roll that up and polish it like this. So the seat bore is polished smooth. Now the needle has less resistance to getting caught on the sides and sticking. Now, later, more modern carburetors, they made improvements by having a little wire bail that connects to the float so that it won't get stuck. But on these old carbs, the needle can get stuck on the sides if that needle seat bore is not polished. So when this goes into the carb body, it has an O-ring and gets pressed in, and it's held in by this clip. The floats, we want to be sure that they're in good condition, that there's no holes leaking and there's no fuel. You can shake these and see if there's any residual fuel inside. These do not, so these should be in good shape. The needle drops in, and then the The float itself is held in by this pin. The needle itself has a plunger which is held in by a tiny spring inside. So you want to make sure that that plunger is moving free. I always consult the spec book for your float level. That's 26 millimeters. Make sure that you use that measurement and don't change that. Float level is not a carburetor tuning parameter. If you want to rejet your carbs for different performance, you change the jets, but not the float level. To set my float level, what I'll do is I'll tilt the carb body until the tang touches the float needle. And you can see there's spring-loaded plunger up top. I don't want to compress this plunger. I want to tilt it till the float is just touching. And then I'll take my 26 millimeters and check that measurement right there. If I need to adjust the level, I'll take my screwdriver and just bend the tab a little bit. Next, I'm going to install a float bowl. First, the spring clip needs to hold down the two jets, the main jet, and then the primary main jet. The grooves are two different sizes for the larger and the smaller of these jets. The pilot jet gets covered up with a rubber plug. This is so that the pilot jet only gets fed fuel through a drilled passage from the primary main jet. Float bowl gasket. Now, no glue or silicone on this gasket. If a piece of glue broke off into the float bowl, it'll most likely clog a jet and can cause engine damage. Check that the standpipe doesn't have any holes or cracks in it. All right, next is a drain screw. Takes a fiber gasket. This drain screw has holes drilled, so you want to drain fuel out of your float bowl. You only need to unscrew this about halfway. You don't need to take this out and possibly lose it. I'm going to put the slides in. I'm going to stick my finger in, hold the slide up while I do this. There is a tab on the diaphragm and needs to fit into this groove. The diaphragm all the way around the outside needs to fit into the groove, and I'm going to hold my finger in there. Diaphragm is in place. Spring, and then the cap. So I held pressure to be sure that the diaphragm is not pinched. And my finger inside, I can push up and down and see that it slides up and moves down slowly. All right, I've mounted some ignition coils up top here and some condensers so I can run it on the bench. We'll check ignition timing with a timing light. We'll run through the gears, check our shifting, and then we'll also check oil flow. This is a check bolt up top here. When it's running, we should have oil flow up here.